Hi everyone. Today we are going to take up chapter 5, that is complex numbers. But then question arises that why do we need to introduce complex numbers in mathematics? Children, you must have come across this type of quadratic equation when it is x square plus 1 equal to 0. In this case, after solution, you were getting it like this, or x equal to under root plus minus, this is minus 1. And in class 10th, you have considered this as an imaginary root. But then Euclid's defined this root minus 1 as iota. So Euclid has said if in the roots it is coming under root, that means negative of any number is coming, then you can always replace it with iota. So this is the iota which is introduced by Euclid to denote root of negative of any number. So here first thing we have noticed that minus square root of minus 1 is iota. Then what we can tell the powers of the iotas. So children, if you want to find out iota square, then simply you need to square it and you will be getting it as minus 1. If you want to find out iota cube, then what you can do over here is whenever you are getting an odd power, then you always split one iota out of it. So it will be iota square into iota. Now you know the value of iota square, which is minus 1. So minus 1 and this iota as it is. So I will be getting it as minus iota. If I want to find out iota raised to power 4, then if you are having an odd number, then split one iota from it. But if you are getting an even power, then you try to make into the multiples of 2. So this I can write it as iota square whole square. Now you know the value of iota square, which is minus 1 whole square, which is equal to 1. Similarly, if you want to find out iota raised to power 5, first of all you need to see whether it is an odd power or even power. So this is your odd power. So split one iota from it. So it is iota raised to power 4 into iota. Now iota 4 is again an even power. So I can always write it in the form of iota square whole square into iota. And iota square is minus 1 into iota, which gives me just iota. Children, I always suggest you, whenever you are going to split even power iota raised to power some even power, then you always split into multiples of 2 and not multiples of 4 or 6. Because yes, of course, we are getting iota raised to power 4 as 1 here. The positive value is, this is the first positive value which we are getting over here. But I always suggest you to go by iota square, because this is the base of this chapter. So if you want to find out now iota raised to power 6, then you can obviously write down it as iota square raised to power 3. Now you know the value of iota square, it is minus 1 whole cube. So this is equal to minus 1. So I can conclude from here that if I am getting iota square, iota 4, iota raised to power 6, then the values are coming out to be minus 1, then it is plus 1, then it is minus 1, and so on. That means even power of iota will always have value 1, but with alternate signs. If I talk about odd powers like iota cube, iota raised to power 5 and so on, then I can see iota cube is minus iota here, iota raised to power 5 is iota, and so on. That means odd powers will always be in the form of iota, but in alternate signs over here. So this is the main conclusion we can draw here, that if the powers are even, then you will always be getting the answer as 1, but in alternate signs. That means negative, positive, negative, positive. And here when your iota is having odd power, then you will always get your answer in iota form, and that too in alternative signs, that is negative, positive, negative, positive. But then how you will be finding out if it is iota raised to power 97? If the powers are bigger, then what are you going to do? Always remember, children, first of all you need to see whether this is your even power or odd power. For odd power, you just split one iota, or you just take out one iota from it. So it will be iota raised to power 96 into iota, and then if it is an even power, convert into multiple of 2. So it can be written as iota square raised to power 48 into iota. So this will give me minus 1 raised to power 48 into iota. Minus 1 raised to power 48 will be just 1, and this will give me iota. So this is the case when you are getting the things in the numerator. But what if I get it in the denominator? If it is coming in the denominator, then also you have to split one iota from it. So it will be 96 into iota raised to power 96 into iota. Then again you will be taking it as iota square raised to power 48 into iota, which will be giving me minus 1 raised to power 48 into iota. So I will be getting it as again 1 upon iota. But children, whenever you are doing complex number, you cannot leave the answer in the denominator in iota form. So here you have to rationalize it. So rationalize, multiply iota and divide iota. So I will be getting it as iota square, iota by iota square, which will be minus 1 over here. So I will be getting it as minus iota. So 1 by iota raised to power 97 will give me just minus iota. Now children, this everything I have told you, but this I have told you just about iota and the powers of the iota. But then what about this complex numbers? So complex numbers are the numbers which are represented in a plus iota b form. This is the standard form to represent any of the complex number, where this a is your real number and this is with iota. That's why we call it as imaginary number. Now we can represent real number as RE, and yes, of course, a plus iota b can be denoted by simple z. So this is your complex number whose expanded form you can write it as a plus iota b. So this is your real part of z, and this is your imaginary part of z. What? This b is imaginary part of z. So this is the way we write complex numbers. Now when we talk about algebra of complex numbers, then we can say that complex number satisfies closure law. And what is closure law? That if two complex numbers are added, then you will be getting result as again an complex number. Secondly, it satisfies commutative property, which says, commutative law, which says if you are adding two complex numbers, then you will get the same result if you change their orders. Third, it also satisfies associativity. That means associative law is satisfied. That means if three complex numbers are added in different ways means if I pair up and find the addition of this, and then I am adding it to z3, if the pair is changed, then also you will get the same answer. Fourthly, you can have additive inverse over here. And what will be the additive inverse of any complex number? That means you need to write a complex number additive inverse. That means what complex number you should be writing so as to get the answer 0. So if I add negative of this, then I will be getting it as 0. Then we have additive identity. Additive identity says that by what number or what number should be added to this complex number to get the answer as 1. So 0 is the number, sorry, not 1, is z. 0 is the number which when added to a complex number, it will give you the same complex number. Similar laws will be followed in multiplicative law, or I can say multiplication, algebra of multiplication of two complex numbers. So in multiplication, it will satisfy closure law, it will satisfy commutative law. That means if two complex numbers are multiplied, then you will get result as complex number. If two are multiplied and then order are changed, then again the answer will be same. But in place of additive inverse, there you will have multiplicative inverse. And it says multiplicative inverse. When we talk about multiplicative inverse, then we need to take the reciprocal of the given complex number. Let's suppose z is given to you as a plus iota b. Then if you are finding out multiplicative inverse, then you will be taking it as 1 by z, or simply I can write it as 1 upon a plus iota b. And then we cannot leave the question in a plus iota b form. That's why we have to rationalize it. I am writing it here. When we talk about multiplicative inverse, we write it as 1 by c. That means we need to take reciprocal of z. So this will be 1 upon 1 plus iota b, and then for solution you will be rationalizing it further. When we talk about multiplicative identity, then just now I told you that by what number, if I am taking identity, that means it keeps its identity. So by what number should this be multiplied to get it z? So 1 is the multiplicative identity by which if I multiply this complex number, then the identity remains the same. Now children, I am going to introduce you two words. One is modulus and another is conjugate. And you are going to use these two words many a times in this chapter. So first of all, let's know about modulus. Modulus means we need to find out, modulus is the resultant. That means you need to find out the square or sum of square of your real part and imaginary part. So if this is the complex number and if you want to find out the resultant of this complex number, then it will be real part square plus imaginary part square. So it will be like this, imaginary part square. So what is your real part over here? It is a square plus what is your imaginary part? This is b. So this is b square. So this is modulus. That means we are finding out the sum of squares of the real part and imaginary part, and then we are putting it under root sign. Now if I talk about conjugate, conjugate means you have to change the sign of the imaginary number. If it is z equal to a plus iota b, and if you want to write down conjugate, conjugate is represented by this way. If you want to write down conjugate of this complex number, then you need to simply change the sign of your imaginary part. If it is positive, make it negative. If it is negative, make it positive. Now children, modulus and conjugate, they have a relationship. That means if you multiply a complex number with its conjugate, then you will always be getting square of its modulus. So this is an important formula that you are going to use in this chapter. So have a look.